What is up, guys? Welcome to Bardent. My name is Heinrich, and today we're going to refactor our player a bit. We're going to introduce the core. The idea of the core is basically just a collection of scripts that hold some basic functionality that our entities like our player and enemies will likely need to access. So this includes the code for like setting the velocity, how the entity senses the environment around it, how it's going to deal with combat, its stats, and things like that. The goal is to hopefully end up with some components that we can just drag and drop onto new entities that we make in the future and just have them easily integrate with the system that we currently have. Now, I would like to give credit for the idea of the core to Adam C. Yunus. I saw his similar system while watching some of his streams, and it just made so much sense. I can't promise that my solution is as elegant as whatever he has made, but this is my attempt and I'm very happy with it. So yeah, if you've not seen his videos, definitely check him out. There will be a link in the description. So let's go ahead and get started and just discuss the core a little bit more. As you can see, it's very simple. Essentially what we have is this single script that we're just going to call core, and our enemies, player, NPCs, anything else that need to have access to all of these things over here is going to implement the core. The core is going to sit on a child game object for these entities, and then each one of these scripts will be on children of the core. So that means now when a state wants to set velocity for our player, instead of having to call a function on the player, it itself will have a reference to the core. So when the player sets up its states, it'll give it a reference to the core. And then when it sets the velocity, it simply goes core.movement.setVelocity. And so once we have all of our set velocity functions in movement, we don't ever have to write that code again for different entities. Because as you know, currently our enemies and player all implement that function. Now, I mean, going back and changing that is a little bit of work, but I think it's worth it moving forward. It'll make everything a little bit more compact and neat and standardize things just a little bit. So as you can see, our core is going to have references to our movement script, this collision senses script, which is basically just going to hold things like ground detection, wall detection, ledge detection, all those fun things. And then combat is just going to deal with combat related things, mainly taking damage. And then, yeah, we'll get into the rest of these scripts as we move down this list. So our focus for today is just going to be implementing movement and collision senses on our player. And that means next episode we can move on to our combat script, which will start handling how we deal damage with our weapons. So yeah, let's go ahead and get started. Okay, so let's start off by navigating to our scripts folder over here, and let's just go ahead and create a new folder called core. So this folder is going to contain our core script itself and then all of the core components. That's what I'm going to call them as well. So let's start off by creating a new C# script, and we'll just call it core. Before we open this, let's go ahead and create another C# script. And this one I'm just going to call core component. So really on that previous diagram, it should have shown that each one of those scripts of movement, combat, collision senses, all of them, they're going to implement core component. And you'll see why in just a second. Okay, so let's go ahead and open up both of these. Okay, so there is core and then our core component, just like that. And we can just go ahead and get rid of our initial code. Okay, so before we do anything here, let's go back to Unity and let's create a folder within our core folder. And I'm just going to call it core components. Like that. And I'm actually going to drag core component into core components. And then let's open that up. And then in this folder, let's go ahead and create a new C# script that we'll just call movement. Let's go ahead and open that up as well. And let's just get rid of this pre-generated code. Okay, so let's again just think about this. What's going to be the purpose of our movement script? The purpose is to have a set of functions that set the velocity of our rigid body. So if we take a look at our player script, we can just come over here, come to player finite state machine and open up player. So in here we have this set functions region. If we expand this, we have all of these set velocity functions, set velocity 0 for different angles, our X and Y, things like that. If we go ahead and look at our enemy script, so enemies, state machine, and then entity, we have some similar functions here. We have these two set velocity functions. So, you know, we're constantly rewriting these functions. So instead, let's just go ahead and move it to our movement script. Bear in mind that this is going to cause a lot of errors, but we're just going to work through it slowly, fix all of our errors, and yeah, it's a good exercise in refactoring your code. So let's just go ahead and select all of these functions, including the region. And then if we hit Control X to cut it, we can just go ahead and paste it in our movement script. Just like that. So now they're all here. Okay, so immediately we're greeted with a lot of errors, and that is 3 different variables that we don't currently have. We have rigid body, because obviously our movement script needs access to our rigid body in order to be able to set the velocity. And then we have our storage container for our current velocity, and then our workspace. So let's go ahead. The easiest one to fix right now is going to be current velocity and workspace. So above the region, let's just go ahead and declare a private vector2, and we'll just call it workspace, like that. Okay, there goes those errors. Next, we have our current velocity. This one is going to have to be public, because we also want to be able to reference our current velocity through our movement script. So public vector2 called current velocity, like that. And don't forget to give it a public getter, but a private setter. Just like that. Now, finally, we have this rigid body component. Now, because movement generally deals with rigid body component, let's go ahead and just leave the reference in movement. And then whenever our states needs to reference our rigid body for some reason, we can reference it through our movement script. So at the top, let's just go ahead and declare another public rigid body 2D, and we'll just call it RB. And don't forget to give it a public getter and a private setter. Now, before I forget, we want to make it so that our movement script inherits from our core component instead. And the reason for this is we want to give our movement script and our combat script, all of those things, access to our core so that they can talk to these other components as well if they need to get things or call certain functions from there. So in our core component, we're just going to set that reference, and then all of the components will have it. And then if there's anything else that need to be shared between all the components, we can go ahead and add it in here. So in here, let's just go ahead and declare a protected core, and we'll just call it lowercase core, because this will not be made public via getter. Okay, now, so to get the reference to the core, we'll do that in the awake function. So private void awake, and then in here, all we say is core equals transform.parent.getComponent. And the type we're looking for is core, like that. Now, the reason we use transform.parent is because we said that our movement script, which is a core component, is going to be a child of the game object that holds our core script. So this should work. Now, a good thing to put in here is just, let's just give ourselves a warning if we forgot to add the core on our parent script. So we'll say if core equals null, so the script was not found, then we're just going to debug.log error, and the error is just going to be there is no core on the parent. Like that. So now all of our components will check that by itself, and we'll get an error if we forgot something. Perfect. Now, back in our movement script, we have this rigid body component, or this rigid body variable. So we need to set this reference as well. And a good place to do that is going to be the awake method as well. But now, seeing as we inherit from core component, that means we need to come back here and change it from private void to protected virtual void. That means we can come back to movement and over here, override our awake function. So we can just say override awake, like that, and it should autocomplete everything else. And we want to keep base.awake so that we set the core reference. And then we can just say rigid body equals get component. But this time, our rigid body is on our uppermost parent game object, most likely. So instead of just get component, we'll just say get component in parent. And the component type that we're looking for is our rigid body 2D, like that. Perfect. So we dealt with get component in parent before. Basically, it's going to recursively look on its own game object and then the parent and parent and parent until it finds the rigid body 2D that it's looking for. Okay, so now for all of our states to have access to these functions again, Because if we look at Unity, you'll see we have a bunch of errors, and it's basically just saying, oh, player script does not have a definition for these set velocity functions that I'm looking for. So our states need to know about the core. Let's go ahead and come back to our player script, and let's open up components. And then in here, let's just go ahead and declare a public core like that, with a public getter and a private setter. And then in our Unity callback functions, in the awake function, before we initialize our states, let's just go ahead and say core equals get component in children core. Now our states need to know about the core. We don't want to go player.core.movement, stuff like that. We just want our states to know about the core and have this functionality available. The idea is to hopefully be able to move to a position where our enemies and our player can share a single state hierarchy without having two different separate like state machine systems that we've coded, and just have everything work the same. So this will take us one step closer. To do this, let's go ahead and open up our player's state script. Eventually we'll probably move away from having a player state script, like I said, but for now, let's just get the core part working. In here, we'll go ahead and declare a protected core, and we'll just call it core, like this. Lowercase core, of course, there's no public getter, anything like that. Okay, so how do we set this reference? Well, we want the same core that our player has. Basically, we want the core that our entity is using. So we want the entity to set up the reference to the core in the constructor. Now, currently we have this constructor that takes in the player script, the state machine, data, animation, boolean name, things like that. So somebody pointed out that I really don't need all of these state machine and player data input into the constructor, because we have a reference to the players. So over here, we can just say state machine equals player.stateMachine and player data equals player.player data. For now, we'll just make use of that system instead, so we don't have to go through and change the constructor on all of our states. So we have this protected core. In here, we can just say core equals player.core. Now, I did say we don't want this state to be reliable on the player script, but we'll change that eventually. I think it's going to be a pretty big upgrade. For now, this will work. Now, all of our states has a reference to the core component, which means they have a reference to this movement. Well, not yet. We still have to set that up. So let's do that. Let's come to core. And in here, we can just go ahead and declare a public movement, and we'll just call it movement, like that, with a public getter and a private setter. And now when we have a reference to the core, we have a reference to our movement script. So now to set the reference for movement, we're going to make use of the awake function again. And in here, we just say movement equals get component in children. And the type we're looking for is movement. And now seeing as our movement script is going to be on a child game object of our core, this should find it. Let's go ahead and just add a check in for ourselves again to make sure that we didn't forget it. So we'll say if not movement, basically the same thing as saying movement equals null. You can use whichever one you want. Then we'll just say debug.log error, and our error message is just going to be missing core component, like that. And now the reason I'm not specifying here is because as we add our other core components, I'm just going to add an OR in here so that if we're missing any of them, we'll get just this error. We don't really need to know which one. We can figure that out quite easily. Okay, so now that we have all of that set up, we can start tackling these errors. As you can see over here, we currently have 19 of them. Now, I'm going to show you some tricks that we can use to fix this quite quickly. To start off, let's just click on the first one. Start at the top, work our way down. As you can see, this error is in our player attack state. Player.setVelocity does not exist. Now, we know that this has changed from player.setVelocity to core.movement.setVelocityX. So we'll just go ahead and highlight player.setVelocity without the X. And then if you hit Control F, it should pop up with this find box over here. Now what you can do is this doubles as a find and replace. So you can see here toggle to switch between find and replace modes. So if we click on this, it adds the second box down here where we can specify what we want to replace it with. So we can go ahead and get rid of that, and we can just say anywhere where it says player.setVelocity, we want to replace that with core.movement. movement dot set velocity. Like that. And I'll just make sure everything is right. Otherwise, you're going to still have errors. Now, if you hit enter, you'll see that it'll replace this, the one that we highlighted, with this. And then it'll automatically move on to the next one. So if we just hit enter once, boom, you can see up here it's changed it. And now it's highlighting this one for us. This is the next instance of what we're searching for. Now, another thing to point out real quick before I forget, before we move on, over here it says current project. If you click on this drop down, there's a bunch of different options you have here. And this is just where you can select where it should look for this thing that you're trying to find. So if you didn't want to accidentally change things outside of this document, you go ahead and select current document. For me, I want to replace it everywhere in the project, so I'm just going to set current project. So let's go ahead and hit enter again. There we go. As you can see, we don't really see that it changed, but just take my word for it. If we look at it over here, you can see it changed, and it opened up the next document where it found this thing that we're looking for, player.setVelocity. So we can just keep going. Let's just keep hitting enter, and you can just look to make sure that you actually want to change this. So yeah, we want to change this one. Boom. Player.setVelocity y. Yep. Player.setVelocity. Change it. Change it. Change it. And then just keep going. Boop, boop, boop. Until it tells you that, hey, I've run out of things to change. I no longer see player.setVelocity. So you can see it comes up with this pop-up. No more occurrences found in the specified documents. Awesome. Click OK, and I can see we have all these unsaved documents. A quick way to save it is to hit Control K, and then let go of Control and hit S. It should save it. I think that's the shortcut key. That's the shortcut key I have. Another way is just to come up here to File, and you can say Save All. It should tell you the shortcut over there then. Okay, so now that we have all of them saved, let's go ahead and look at Unity again. Just let it compile. Boom, all of our errors are gone.
More are coming.
Okay, so let's run it and make sure that everything still works. We're gonna have a couple of issues still. As you can see, the issue is that we didn't set up the core yet. Okay, so go ahead and open up the player, right click on it and say create empty. I don't know why it's not creating a child, but it's fine. Go ahead and rename this game object to core. And I'm just gonna move it up to the top underneath player. And then I'm gonna right click on that and say create another empty. And this is going to get called movement. Like that. Now click on core and then hit add component and just add the core. And then click on movement, add component, movement. Just like that. Now if we run the game, as you can see, we can still move left and right. Now we're gonna have an issue when we jump. And that is, that. Okay, so now to fix that, first we need to determine what is our issue. Well, here's the issue. Let's go ahead and just close all of these state scripts. We don't care about those anymore at the moment. What I care about is my movement script. Now, as you can see here, we have this current velocity variable. What is our current velocity? Well, it's a place where we store what our current velocity is. A lot of our states make use of current velocity. Like, for example, in our jump state, I think, which I just closed, but let's go ahead and open that up again. Player jump state. No, not our jump state, our player in air state. That's what I'm looking for. In this state, we pass our current velocity through to our animator to display the correct animation. In some of the states, we make use of current velocity for our logic to determine when to change between different states. So our states are still currently referencing player to current velocity, but that's not the current velocity we want to use anymore. If we come to player, you can see over here we have in update, current velocity equals rb.velocity. So we want to go ahead and just get rid of this. Okay. And then actually, to just point out where else we need to get rid of it, let's go ahead and get rid of the variable altogether. So in other variables, over here we have this public vector 2, current velocity. Go ahead and get rid of that. If you're worried, just comment it out for now. so you don't have to risk losing code. But yeah, I'm confident because I use Git. Okay, so now that we've gotten rid of that, we can go back to Unity and let's see what kind of errors we get. So we have 13 places where we make use of our current velocity. Now, that means, of course, that we need to reference our current velocity in movement. But before we forget, we just deleted the code in update where we set our current velocity every frame. So let's go ahead and do it in our movement script as well. Now, we're not going to make use of update in here because if we take a look at our player, if you remember correctly, imagine the code is still here, we set our current velocity before we did our state logic because we wanted our state logic to have access to the most recent current velocity that we know of. So instead of using update in our movement script, we're going to create an update function for it, and then we're just going to call that from core, and that's going to get called from our player. So underneath awake, let's go ahead and declare a public void logic update like we have for our states. And in here, we'll just say current velocity equals rb dot velocity. Okay, then we can come to our core function or our core script and underneath awake do the same thing. So public void logic update. And then in here, we're just going to say movement dot logic update. So this means that all of our core components will have the option to have a logic update function, and we'll just call that from core in a list over here. And then from our player script or whatever's implementing the core in the update loop, we just say core dot logic update. So now we can control that we want our current velocity to update before our state logic. Okay, so let's do another round of error fixing. So again, let's just start with the top one. This takes us to our player dash state. So you can see over here, we said if our current velocity.y is greater than 0, we want to do this. So again, we can just do the same thing. We select player.current velocity, hit Control F. We can come up here to the right again, change it to find and replace mode. And now instead of player.current velocity, it's going to be core.movement.current velocity. Just like that. Okay, now we can go ahead and one by one replace them all. So boop. Okay, replace that one. And again, we can just keep going until it says no more occurrences found. So hit a K, Control K, S to save everything, and then back on Unity. Let's see if everything worked. Perfect, we don't have any errors. As you can see, we can jump again and everything works like it did before. Perfect. Okay, now the next thing I'm going to move to the movement script is our flip logic. So if we click on our player script, we come to other functions. Over here, we have our flip function. Essentially, all it does is change the rotation of our transform and sets the facing direction directly. So this is also involved with our movement. So it makes sense in my mind to move it to the movement script as well. So let's just go ahead and cut it, come over to movement. I'm going to add it below all the set functions. So here, private void flip. And now if we come back to player, there's another part of this, and this is just the check if should flip function. So where do I have that? I think it's in the check functions. Yep. So here we have check if should flip. Cut that, come back to movement, add that in here. So now again, we have an error, and that is our facing direction. Now our facing direction is also pretty pivotal to our movement. So it makes sense for us to declare it here. So I'm going to add it above our current velocity, and it's just public int facing direction. And don't forget to give it a public getter and a private setter. And now, yeah, that's all we need to do to add this here. And again, errors. Let's see what we need to fix. Hello? Oh, make sure you save your scripts, of course. There we go. Okay, so 6 places that use check if should flip. So start with the first one. So player.check if should flip. We know this needs to be replaced with something else. So Control F, change it to find and replace. And of course, now instead of current velocity or core.movement.current velocity, we're just going to say core.movement.check if should flip. And then, yeah, hit enter to replace and just keep going. Make sure you check to see you're replacing what you actually want to replace. And there we go. No more occurrences found. Hit OK, hit Control K and then S to save everything. Come back to Unity. All the errors are gone. Now let's run the game and make sure we can still flip. Huh, we cannot. Oh, I know why. Okay, so another thing we forgot. If we come to our player script, we basically moved our facing logic to our movement script, but we still have this facing direction variable over here. So that's actually why it's a good idea to comment it out or delete it when you start making changes like this, so that all the errors indicate to you where you need to go make changes. So let's save that, come back to Unity. Okay, so there's more places. Here is the places where we reference facing direction for some logic. So click on the first one. As you can see in our ledge climb state, we compare our X input to our facing direction. Now, again, we know instead of player.facing direction, it's going to be core.movement.facing direction. So select this, Control F, turn it to replace mode. And now instead of check if should flip, we just change it to facing direction, like that. Hit enter and replace all of them. There is a replace all button as well, but I like to go through it slowly one by one just to make sure I want to replace those specific lines. Okay, hit OK, hit Control K and then S. And now before we go back to Unity, there's another thing we need to do, and that is just that we need to initialize our facing direction. So if we come to our movement script, which is over here, our facing direction needs to be initialized to 1. And we can just go ahead and do that in awake. So we'll say facing direction equals 1. Perfect. Let's go back to Unity and try it out. Well, did we? Oh, okay. So we also need to go ahead and delete facing direction from the start function in our player script. Okay, now everything should maybe not be fine. Okay, so as you can see, we still have a couple of errors left. Let's go ahead and click on this one. So here are the rest of our check functions. So our ground check and ceiling check and things like that. Some of them make use of facing direction. Eventually these functions aren't going to be here anymore because we're going to move it to their own senses script. But for now, let's just go ahead and fix that. I'm not going to use Control F for this one. I'm just going to say core.movement.facing direction. And then we can go ahead and copy and paste it for all of these. So if we save that, go back to Unity, what other errors do we have? So this one is for our determine corner position function, which also makes use of our facing direction thing. Now, this determine corner position function, instead of fixing this facing direction over here, what I'm going to do is cut this. And the only state that is currently using that is our ledge climb state. So let's just go ahead and move it in here. I'm just going to add it at the bottom. So public vector2 determine corner position, and we'll change this to private, seeing as this is the only state that needs this. And now you can see we have another buttload of errors, but it's okay. We'll take it slow, work through them one by one. One that pops out that can easily be fixed is our workspace. So let's just go ahead and declare a workspace for the state. So workspace is a vector2, so private vector2 called workspace, like that. That makes it a little bit more manageable. Another error we can quickly fix is just to remove player dot in front of determine corner position. And now in our corner position over here, unfortunately we can't fix all the errors yet, but we can fix the facing direction errors. So instead of facing direction, like we said, it's going to be core.movement.facing direction. Go ahead and copy that and just paste it in for all of the facing directions. That's all of them. Now, as you can see, we have these errors for wall checked up position, ledge checked up position, and things like that. we can't fix that yet because before we can do that, we need to go ahead and create our collision senses script where we're going to put these things, and then we're going to get these positions by referencing our core. So yeah, let's do that. So let's go back to Unity, and in our core components folder, let's go ahead and create a new C# script. And this script I'm going to call collision senses. So let's go ahead and open that up and then just get rid of the pre-generated code. And now instead of mono behavior, again, it's going to be core component, just to get that core reference set up quickly. Now, what are we going to put in here? Well, like we've established already, this is going to hold all of our ground detection, wall detection, things like that. So let's come over to player. That basically just means it's our check functions. So all of these. So let's go ahead and select all of them. Control X. Just get rid of the region like that. And then come to collision senses and paste it in. So now let's go ahead and fix these errors. Mainly we need our check positions back here. So let's come over to player. Scroll up. Over here we have our check transforms. Let's just go ahead and cut that. Save. Come back to collision senses and paste it in here. Cool, so that gets rid of most of the errors. Now, as you can see, we have an error with our core.movement, and that is just, this needs to be a lowercase c, like that. And then finally, we have an error with our player data. Now, because we don't want this collision senses component to be reliant on player data, we want to make these variables, or ground check radius, all these things, components of collision senses. It's important for them to be here. So let's just go ahead and declare these variables. So we'll create a serialize field, and the first one is going to be a float called ground check radius, like that. And I actually like this way of putting serialize field now, so I'm just gonna move all of these. Makes it feel a little bit less cluttered. Okay. So after ground check radius, we have our layer mask. What is ground? So serialize field. Whoops. This needs to be private float. I mean, it's private by default anyway if you don't put private there, but let's just be consistent. So we have private layer mask. What is ground? Like that. And then finally, we just have our wall check distance. And that's also a float. So serialize field, private float, wall check distance. Like that. Now we can get rid of player data dot for all of these. You could use find and replace to get rid of things quickly, but you know, you don't always need to be quick. But it does help not miss anything, that's for sure. Is that? No. Then down here we have our last one. So this needs to be lowercase c. Get rid of player data and player data. Boom, and that should all be fixed. Now, another thing that I want to do is instead of having this check for ceiling, check if grounded, check if touching wall functions, I want to change them from functions into properties. I'm pretty sure properties is the right word. Please correct me if I'm wrong. Pretty sure that's what it is. So that in our code, when we're looking to see if we're grounded, we're not going to say core.collisionsenses.check if grounded. We're just going to say core.collisionsenses.grounded or .ground, just to see what that variable value is. Really, there's no functional benefit to it. I don't think. It just looks prettier. And you know, sometimes it's nice to create good looking code. So how do we turn these into properties? Well, like that. Not quite. As you can see, we have lots of errors, but basically now we have this public Boolean check for ceiling variable. It's our property. We're going to give it a getter that just returns this. And to do that, all we simply do is instead of return, we just say get and then equals and then the greater than symbol. So this arrow. it's essentially doing the exact same thing as our normal public getter private setter thing that we're doing. But instead, what it's doing is when you say check for ceiling, so when you look at this property, it returns this. So in here, in this get, you could have a function that it calls that returns something that then gets returned to whoever's looking at check for ceiling. And now instead of calling it check for ceiling, I'm just going to call it ceiling. Now, if you don't quite understand what's happening here, I highly recommend just reading up a little bit more on how getters and setters work with C#. It's pretty interesting, but as far as I understand it, all that's happening here is we have this ceiling variable, and with this code over here, when the code compiles, it's going to create a getCeiling function that has this as the body of the function. And then when we call ceiling, or when we look at ceiling, it's going to call that function automatically for us. If we look at like our movement script, this get and private set functions over here does the same thing. We have this RB variable. There is a auto-generated get function and a auto-generated set function. Get is public and set is private. This is just shorthand, meaning we don't have to write the get and set function ourselves. That's all we're doing here. Now to just quickly change all of these over, we know that we want to replace all of these returns with this. So I'm just going to go ahead and highlight return, hit Control F, change it to replace mode, and we'll just say get space equals, and then greater than, and then boop, 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 all of them. Now, as you can see, because we have this set to current project, it's taken us to the next return, which we don't want. So go ahead and close that and come back to collision senses and then just save. Now, as you can see, it's giving us a bunch of errors because these are functions, not properties. So just get rid of the brackets at the end. And there we go, no more errors. Now I'm just going to rename some of them. So instead of check if grounded, we're just going to call it ground. And then instead of check if touching wall, we're just going to say wall front. And the reason I say front here is because we have this back wall over here, which we're just going to change to wall back. And then finally check if touching ledge, we'll change to ledge. Just like that. Easy peasy. Okay, now let's head back to Unity and see what errors we have. We're going to have quite a few, but you know, we have such a great tool to fix all of these now. It's actually kind of fun. So let's start with the first one. So we're missing player.checkIfGrounded. Now we know what we want to replace this with. So we're just going to select all of this, hit Control F. Notice that I did not select the semicolon at the end. Now this we're going to replace with core.collisionSenses.ground. We can go ahead and hit enter, replace that and that and that until it's done. Okay, so no more occurrences found. Hit OK, save it. Oh, did I make a mistake? Core does not oh, okay. So the reason this is still giving an error is because we did not add collision senses to our core yet, which is quite important. So let's come over to core. So we'll just say public collision senses, and we'll call it collision senses. And don't forget to give it the public getter and the private setter. And then once we have this, in the awake function, we'll say collision senses equals get component in children. And the component we're looking for is collision senses. Just like that. So now, yep, our core.collisionSenses.ground is working. Okay, so now we can go ahead and fix our player.checkIfTouchingWall. So just select that, hit Control F, change it to replace mode, and now instead of ground, we're gonna say wall front. Now as you can see, I don't have the brackets at the end because I'm not calling a function, I'm looking at a property. So hit enter to change it, change, there we go. All of them have been changed. Make sure there's no errors. Perfect. Okay, what's next? Our wall back is missing. Now I think we only have one of these, but regardless, just select it, Control F, and now instead of wall front, we have wall back. Yep, okay, so there was only one occurrence. That's okay. Next, we have our ledge check. So select player.check if touching ledge, Control F, change this from wall back to just ledge. Just keep hitting enter until they're all gone. Hit OK, and then I think the final one we have is our ceiling check. Here. So player grounded state, go ahead and select this, Control F, change it to replace mode, and now instead of ledge we have ceiling. And I guess we only have one check. Okay, so that should be everything. Now don't forget to save all of your files with Control K and then S. And let's head back to Unity and see if we got everything. Okay, so as you can see, we still have 6 errors left. Now these are back in our player ledge climb state, and it's just our wall check and ledge check positions. So we're going to reference these through our collision senses, like I said before, but that means we first need to come to collision senses and make these public, or just make them publicly available. Now we could do the thing where we say public, and then add the getter and private setter at the end. That was difficult to type for some reason. But unfortunately, this does not work with this serialize field thing that we have over here. And we have the serialize field over here so that we can drag and drop our references in Unity itself. Now, to fix this is really quite simple. So let me show you how we can get around that. Let's just fix this, make this private again. Now what we're going to do is basically redeclare all of these variables, but in uppercase form. So instead of private transform ground check, we're going to have public transform ground check, like that. So you can see uppercase G, lowercase g. This doesn't matter. You could name this whatever you want, but the convention is you make this the uppercase and this the lowercase. Then in here, you open up some squiggly brackets and we create our public getter. But now instead of just having a semicolon, what you say is equals greater than. So get means we're going to return something. When we get this property, we want to return a variable, and we want to return ground check. Notice, however, that we don't have to type return ground check. We're just saying this is the variable that you need to return when you look at this property. Then we can also put in our private setter. So private set, and then we do the same thing. So equals greater than. And then now we need to say what variable needs to get set when we set ground check. So we're just going to say ground check equals value. And this value refers to whatever value we're passing through when we set ground check. So if somewhere else we were to type, just as an example, ground check equals something like that, value is going to refer to this, the thing we're trying to set it to. And then basically we're just specifying that we want to store this value in ground check. So this is kind of like our internal property, and this is how we interact with it from outside. Cool, I hope that made sense. If you want more of an explanation on this, feel free to reach out. But let's move on and just create the same thing for all of these. Now, instead of rewriting it, I'm just going to copy it and paste it 3 more times. And now instead of ground check, we're going to have wall check, and it's going to return wall check. Again, note lowercase wall check, uppercase wall check. Like that. Next, instead of ground check, it's going to be ledge check. Uppercase L, and then here we have lowercase l and lowercase l. And then finally, instead of ground check, this is going to be our ceiling check. So uppercase C, lowercase c, and lowercase c. Cool, so with that out of the way, we can come back to our player ledge climb state and fix these errors. So now instead of just saying wall check dot position, we need to say core dot collision senses dot wall check with an uppercase W. I'm just going to go ahead and copy this. And now for this wall check, we'll put that in there. And for this wall check, Cool. And now for our ledge check, I'm just going to paste it once and remember to change it from wall check to ledge check. And then I'm going to copy it and then paste it in for the rest of the errors. Like that. Okay, that should be everything. Let's go back to Unity and see if it worked. Cool, no more errors. So there was a lot of things we changed there. We didn't get to test our flipping. And now we just want to make sure that our collision senses still work. So let's go ahead and run the game and see what happens. Okay, so we have some errors and I know what it is. It's because we did not add our collision senses component, and we don't really have an error telling us that. That's because I rushed this part. Let's go back to core. And as you can see, I forgot over here to say or not collision senses. So now if we forget to add this component in the future, it'll tell us this. Then let's come back to Unity and click on our core game object and hit create empty. This one we'll call collision senses, like that. We can then go ahead and hit add component and search for collision senses. And as you can see, now we have references for our different checks. So what I'm actually going to do is click on my ground check, hit control, and select the rest of my checks. And I'm just going to make them children of my collision senses. I can then click on collision senses and just set up all of my references again. So drag in ground check, and then wall check, ledge check, ceiling check, and then I need to set up these variables. So you can go look at your player data to see what they're supposed to be for you. For me, my ground check radius is 0.3 and my wall check distance is 0.5. Then what is ground needs to be ground. So you can also go ahead and come to our player data and just remove those variables. They're no longer needed there. So let's go ahead and do that. So we can come to player, hit on our player data, open that up. And that is these check variables down here. No longer needed. Okay, so that's giving us some errors. Let's see what that is. Okay, that's good that we did that. Points out some more dependencies on our player data that we have. So let's go ahead and fix that real quick. So instead of player data.wall check distance, we want to do the same thing we did for our ground check values. Okay, so we basically want to create these things, but for these three variables. And now I just found, I googled real quick, there's a quick way to do this, and that is we can just select our variable, right click, and come over here to quick actions and refactoring. And then we can just choose encapsulate field, but choose this one, but still use field. So if we hit this somewhere at the bottom over here, for some reason, you can see it generated this ground check radius with our get returns ground check radius and our set sets ground check radius. So cool. Let's see if we can select multiple at a time, just out of curiosity. Encapsulate fields. Cool, so we could have selected all three of them. We could have saved a lot of time by just selecting all of them, but you know what? This is how we learn. So let's go ahead and hit that. It added all three of them down here, so let's just go ahead and cut them, and let's move them up here. Perfect. That means we can come back to our player ledge climb state. And now instead of player data.wall check distance, this is going to be core.collision senses.wall check distance. Let's go ahead and copy this. And now instead of player data, it's core.collision senses.what is ground with a capital W. Let's fix it up here. Do we have any other ones? Yep, over here. I think that is all of them. Let's see. Let's go back to Unity. Boom, and our errors are gone. Okay, so we no longer have the variables as part of our player data. It's all contained within collision senses now. And as you can see, it kind of tidies up our player's hierarchy a little bit. We have movement, collision senses, and these are the checks, or the check positions. Let's run the game and see if everything still works the way we want it to. Well, almost. Let's see what's happening now. So our flip is not working. Why is our flip not working? So let's take a look at our movement script. Okay, so I found the issue. I forgot something. flip used to be as part of our player. Our player script is attached to our topmost component over here. It's our parent of parents, okay? So when we say transform.rotate, transform refers to the transform of the component that the script is attached to. Now, because we moved flip to movement, it is rotating this transform instead of this transform. So all we need to do is, instead of saying transform.rotate, we're going to say rb.transform.rotate, because we have a reference to our rigid body, which is attached to the topmost game object over here. So if we just reference that and look at its transform, which is this one, it should work. Let's see what happens. Yep, everything's working great. Let's see if our wall climb still works, wall jump still works, ledge climb works. Perfect. Okay, so that is it for the refactoring. I hope, however long this episode ends up being, of just seeing errors continuously did not drive you insane. I hope I managed to teach you something new, some tools that you can use when you want to refactor your own code. And we learned something new with the select and quick factoring options, whatever. Awesome. Okay, so yeah, we're good. We're ready next episode to start introducing the actual damage part of our attack. The attacks are waiting for us to implement them, and I'm so excited. So yeah, that's going to do it for this episode. I would just like to say thank you to all of my supporters and wonderful people over on Patreon, and a huge special thank you to Samoon, Clean Vassner, Jeremiah Miranda, Binary Chef SA, Cody Lee, and Pyro Says for being absolute mad lads. You guys are insane. Thank you guys so much for watching, and I hope you guys all have a wonderful day.